Okay, good afternoon. So, yung topic natin for today is module number 9 or stress transformation. So, first i-discuss muna natin kung ano ang isang stress element. So, when a body is loaded by normal and shear stresses, we can consider any point in that body as a stress element. So, ito yon, yung stress element natin. Denote tau xy and tau yx. And then, the most general state of stress at a point may be components. So, ito nga yun, no? So, sigma x, sigma y, sigma z are normal stresses. And tau xy, tau yz, and tau zx are shearing stresses. So, take note lang natin na ang tau xy is equals to tau yx, tau yz is equal to tau zy, and tau zx is equals to tau xz. So dito, no, yung example natin is 2D element, kaya wala tayong Z element natin dito. So magiging focus lang natin, no, for our subject is yung mga 2D elements lang. So discuss natin ano ba ang plane stress. So plane stress is a state of stress in which two faces of the cubic element are free of stress. For the illustrated example, the state of stress is defined by sigma x, sigma y, tau xy, and sigma z equals to tau zx is equals to tau zy is equal to 0. Next naman natin, no, from stress element is gumagamit tayo ng stress transformation equation. So the stress transformation is a way to describe the effect of combined loading on a stress element at any orientation. And para ma-derive ito is gumamit tayo ng geometry and equilibrium conditions. So kung gusto nyo i-check yung derivation ng formula, is pwede tayo mag-refer doon sa reference book natin and sa learning module. So ano yung mga formulas natin dito? So yung sigma x prime natin is equals to sigma x plus sigma y divided by 2 plus sigma x minus sigma y over 2 times cosine 2 theta plus tau xy sine times 2 theta. And then yung sigma y prime naman natin is quantity of sigma x plus sigma y over 2 minus quantity sigma x minus sigma y times cosine 2 theta over 2 and minus tau xy sine 2 theta. And then yung tau xy prime naman natin is equals to negative theta x minus, negative sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So, saan natin kukunin yung sigma x, sigma y, and tau xy dyan? So, dito natin siya kukunin, no, sa figure natin. So, yung sigma x natin is ito siya, no? Nag-a-act siya doon sa x phase. And kapag nag-a-act naman sa y phase natin, is yun yung sigma y. Paano naman ang sign convention natin pagdating sa shear stress natin? So, ang sign convention natin, no, sa shear stress, pagdating dito sa stress transformation, is counterclockwise positive. So, kapag nirorotate yung stress element natin, for this example is tau xy, nirorotate niya yung element natin ng counterclockwise, ito is positive. And kapag naman nirorotate niya ito ng clockwise, ito naman ay negative. So, para mas maintindihan ninyo, is i-apply natin ito dito sa example. So the state of plane stress at a point is represented on the elements shown in the figure. Determine the state of stress at this point on another element oriented 30 degrees clockwise from the position shown. So ito yung given nating stress element. So syempre first step, given, required, and then yung diagram. So no, for this type of example, no, kailangan nyo lang i-redraw itong stress element natin. So given tayo ng tau x or sigma x, na negative 80 megapascal. Again, kaya negative kasi ito ay compression. Sigma y is equal to 50 megapascal. So kaya naman positive kasi ito ay tensile. Ang tau xy natin is negative 25. So, bakit negative 25? Kasi nga, di ba ito, ang tendency natin is niro-rotate natin ito in clockwise direction. Whereas, sa stress element is clockwise negative tayo. So, next naman, yung theta natin is 30 degrees. So, negative din siya kasi ang yun nga, side convention natin dito is clockwise negative. Kasi given naman dito na clockwise orientation. So, ano yung hinahanap? So, yung transformation natin na denoted ng sigma x prime, sigma y prime, and tau xy prime. So, direct substitution lang ito doon sa formula natin. So, again, ito yung formula natin. Sigma x prime is equals to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 times cosine 2 theta plus tau xy sine 2 theta. And then, input lang natin dito no, sa problem natin, yung mga given parameters natin. So, kung gusto nyo i-check na yung dimensional analysis, so ang matitira na unit sa atin dito ay megapascal lang naman. So, ang magiging final answer natin dito is for sigma x prime is negative 25.84936 megapascal. So again, yung answers natin, ipakita nyo up to 5 decimal places. So next, proceed tayo sa sigma y prime. So sigma y prime, yung formula natin, ipakita nyo lang din. And then, ipakita nyo rin yung substitution ng mga parameters natin. And directly inputting it in your calculator. Ang makukuha nating sagot is negative 4.15064 megapascal. And lastly, tau xy prime, yung tau xy prime natin is negative sigma x minus sigma y divided by 2 times sine 2 theta plus tau xy cosine 2 theta. So substituting the given and directly inputting it in your calculator, ang makukuha natin sagot is negative 68.79165 megapascal. After nating makuha yung mga sagot, so kailangan nating ipakita yung naging transformation sa stress element natin. And then, i-drawing nyo lang yung stress element and i-label nyo ito. So again, since puro negative yung nakuha nating forces, gagaya nung kanina na sa sigma x, is negative 25.8 megapascal. So ito ay compression. And sigma y natin, or sigma y prime, is negative 4.15 megapascal. So pababa naman ito. So negative din, kaya ito ay compression. And then, ang nakuha nating tau xy prime ay negative din. Kaya ang nangyari dito is pababa naman siya. Kasi sabi nga natin kanina, kapag niro-rotate ang orientation natin no, pagdating dito sa stress element is counterclockwise positive. Okay, so next topic natin is principal stresses and maximum shear stress. So sabi dito, if material failure is what we ultimately care about, then we really want to know what are the maximum and minimum normal stresses and maximum shear stress. Kasi dito, no, with regards to detecting or predicting failure, is magagamit natin dito yung principal stress. Kasi nga, ang principal stresses natin is yung maximum and minimum stress. So, di ba ito nga, sinabi dito, they are the maximum and minimum normal stresses. And it occurs when the stress element is rotated such that shear stress is zero. So the equation for this can be found from the stress transformation equation by differentiation of d theta divided by, d sigma divided by d theta is equal to 0 and some algebraic manipulation. So these two values with sigma 1 is greater than or less than sigma 2 are called the in-plane principal stress. And the corresponding planes on which they act are called the principal planes of stress. Take note that no shear stress acts on these principal planes. So ano ba yung positive or yung maximum stress natin dito? So ang maximum natin is yung sigma 1 and then yung minimum natin is denoted by sigma 2. Okay, so next naman dito is pinakita lang yung derivation ng mga formulas natin. So gaya nga nung sinabi kanina, di ba, i-equate natin no, yung sigma equations natin with respect to theta is equal to 0. So dito na makikita lang, dinetermine na ang theta natin is equals dun sa theta sub p or yung principal angle natin. So solving no for principal angle natin, ito yung makukuha nating formula. So tan 2 theta sub p is equals to tau xy divided by sigma x minus sigma y over 2. So the solution daw na makukuha natin dito ay merong two roots. So theta p1 and theta p2. Specifically, the values of 2 theta p1 and 2 theta p2 are 180 degrees apart. So theta p1 and theta p2 will be 90 degrees apart. Substituting this angle into the stress transformation equation, for sigma x1, we obtain the root of sigma 1 and sigma 2. So again, ang sigma 1 and sigma 2 natin is yung principal stress natin. So sigma 1 plus sigma 2 is equals to sigma x plus sigma y divided by 2 plus minus the square root of quantity sigma x minus sigma y over 2 squared plus tau xy squared. So yung sigma 1 natin kapag ito is positive and kapag negative naman is sigma 2. And paano naman kapag maximum in plane shear stress? So the orientation of element that is subjected to maximum shear stress can be determined by taking the derivative of shear stress transformation for tau x prime y prime with respect to u and setting the results equal to 0. So ang makukuha natin ditong formula is tan 2 theta s or theta sub s is equals to negative theta x minus theta y over 2 divided by tau xy. So the two roots of this equation, so theta S1 and theta S2, can be determined from the shaded triangles shown in the figure. So ito yung figure na sinasabi dito. So since tan 2 theta S is the negative reciprocal of tan 2 theta P, then each root 2 theta S is 90 degrees from 2 theta P. And the roots theta S and theta P are 45 degrees apart. Therefore, the element subjected to maximum shear stresses must be oriented 45 degrees from the position of an element that is subjected to principal stress. So the maximum shear stress is given by the formula square root of quantity sigma x minus sigma y over 2 squared plus tau xy squared. So here, the tau max in plane is referred to as the maximum in plane shear stress because it acts on the element in the xy plane. The average normal stress on the plane of maximum in plane shear stress is, so sigma average natin is sigma x plus sigma y divided by 2. And then ito yung magiging denotion natin pagdating sa diagram. For this slide, no, pinakita lang dito yung summary of formulas natin. So average stress natin is sigma x plus sigma y over 2. Orientation of principal planes is tan 2 theta p equal to tau xy divided by sigma x minus sigma y over 2. Principal stress naman natin is sigma x plus sigma y over 2 plus minus square root of tau x, sigma x minus sigma y over 2 squared plus tau xy squared. Maximum shear stress natin is tau max is equal to square root of sigma x minus sigma y over 2 squared plus tau xy squared. And ang orientation naman na maximum shear stress natin is given ng formula na tan 2 theta s is equals to negative sigma x minus sigma y over 2 divided by tau xy. So dito no, kung papansin nyo, yung principal stress natin is combination lang siya nung formula ng tau max and then nung average stress natin. Kasi ito, di ba, ito yung first part natin dito is galing ito dito sa formula na to. And then ito naman yung second part ng formula natin is itong formula na ito. So para mas maintindihan natin, no, i-apply natin ito sa example. So for the state of plane stress shown, determine A, the principal planes, B, the principal stresses, and C, the maximum shearing stress and the corresponding normal stress. So ito no yung given natin. So first step syempre given, required, and then yung diagram. So given natin sigma x 50 megapascal, sigma y since going papunta siya dun sa element natin, so negative. And then since ang object natin, yung tau force natin is may tendency no to rotate the object clockwise kasi ito ay positive. So tau xy natin is 40 megapascal. And ano yung required sa atin? Ang hinahanap is yung theta sub t, sigma 1, sigma 2, tau max, and yung average stress natin. So again, directly substitution lang ito no doon sa mga formulas natin. So tan 2 theta p is equals to tau xy divided by sigma x minus sigma y over 2. Substitute lang natin yung mga given. So ang makukuha natin no, na 2 theta p natin is 53 degrees, 53.13, and 233.13. So again, para makuha itong pangalawa, no, mag-add lang tayo ng 180. Sabi dun sa relationship sa previous slide. So solving for theta p, i-divide lang natin ito sa 2. So bali makakakuha tayo ng 26.56 and 116.56 degrees. So next naman is kunin natin yung principal stress natin, sigma 1 and sigma 2. So again, ang formula natin dito is combination lang ng average stress and maximum shear stress. So direct substitute lang yung mga given natin. So solving for sigma 1 and sigma 2, pwede natin itong i-simplify into 20 megapascal plus minus 50 megapascal. So sigma 1 natin is 70 MPa and sigma 2 is negative 30 MPa. So and then ito no yung diagram natin kapag So again no ito yung magiging diagram natin no kapag drawing lang natin. Again wala pa dito yung shear stress natin. So kulang pa no. Pinakita lang dito yung nagiging itsura. So ito no, pwede nyo rin siya i-denote na sigma 1 or sigma 2. Pwede rin naman max or mean. Wala namang problema doon. So next, ang hinahanap is yung tau max natin and average stress. So again, formula ng tau max natin is square root of sigma x minus sigma y over 2 squared plus tau xy squared. So directly substitution lang no ang stress element natin. So solving for tau max, ang makukuha natin is 50 megapascal. So after natin makuha no yung tau max is hanapin naman natin yung theta s mula sa theta p. Sabi naman doon sa previous slide natin, ang theta s is equal to theta p minus 45. So theta s is equal to 26.56 minus 45. So theta s natin is negative 18 and 17.56 degrees. So after nating makuha yung sigma s, isolve naman natin yung average stress. So sigma x plus sigma y over 2, substitute lang natin yung mga given natin. So 50 minus 10 over 2, and then yung average stress natin is equals to 20 megapascal. So ito no, yung magiging final na diagram naman natin for maximum shear stress. Kasi nga 'di ba sabi natin, nag-a-act yung maximum shear stress natin doon sa plane kung nasaan yung average stress natin. So since yung average natin is positive, so parehas itong tensile. And then yung theta natin dito, so ito no, ang theta natin is negative 18.43 degrees. So ito dapat is theta S na correction lang. So next topic natin is Mohr circle. So it is a graphical method for determining normal and shear stresses without using stress transformation equation. So it is named after a German civil engineer, Otto Mohr. So ito makikita niya yung example ng Mohr circle natin. So kung titignan is parang parehas ito nung Cartesian coordinate system sa geometry. Ang kaibahan lang is yung axis natin dito. So instead of x-axis, ito is sigma axis. And instead of y-axis naman, dinidenote ito as tau axis. So kagaya sa Cartesian system, no, kapag positive yung stress natin or tensile, nandito siya sa kanan. And kapag negative naman is nasa kaliwa. So ang difference ito sa Cartesian coordinate system is kapag yung shear stress natin o yung tau is positive, ang plotting nito is sa baba, and kapag negative naman is sa taas. So kung makikita nyo dito, no, denoted as counterclockwise is nasa baba, kasi nga counterclockwise positive tayo dito. And clockwise naman is nasa taas since clockwise negative. So sabi kanina, di ba, is ginagamit itong Mohr circle para makuha natin yung shear stress and principal stresses na hindi gumagamit ng equation. Kasi pwede naman yun. Pwede tayong mag-estimate or pwede tayong gumamit ng mga geometric consideration. So for a known state of plane stress, sigma x, sigma y, tau xy, so plot the points x, y, and construct the circle at C. So ito no, yung mga formulas natin. Kung titignan nyo, kung gusto nyo i-compute to analytically, is gagamitin natin itong mga formula na to, which is similar lang din naman to doon sa mga formulas natin kanina. Ni-relate lang ito no pagdating dito sa Mohr circle natin. So sigma average is sigma x plus sigma y over 2. And yung r natin is equal to square root of sigma x minus sigma y over 2 squared plus tau xy squared. Where yung principal stresses natin is makukuha natin at point A and B. So ito siya, no? Which is sigma average plus minus R. Isa pang important information na dapat niyong tandaan is with regard sa angles. So angles in Mohr circle are doubled compared to angle in stress element, due to the fact that there is 180 degrees angle between the minimum and maximum stress. Whereas in stress element, the angle is 90 degrees. So kaya dito, no, so kung makikita nyo, kapag ilalabas natin no, yung angle na nakuha natin dito sa Mohr circle natin, kapag ilalagay natin ito dun sa stress element natin, kailangan natin itong i-divide by 2. And kapag magpapasok naman tayo ng angle mula sa stress element papunta dito sa Mohr circle, kailangan naman natin itong i-multiply by 2. Okay, so example natin for Mohr circle. So for the state of plane stress, using Mohr circle, determine A, the principal plane, B, principal stresses, and C, the maximum shearing stress and average stress. So ito no, yung given natin na stress element. So first step, syempre drawing natin yung stress element and then given and required. So yung given and required natin is For the given, meron tayong 50 megapascal na sigma x, sigma y of negative 10 megapascal, and tau xy of 40 megapascal. And then yung required natin is meron tayong theta p, sigma 1, sigma 2, tau max, and average stress. So first step natin dito is mag-locate muna tayo ng dalawang points. So saan natin kukunin yon? So kukunin natin yon dito sa x phase and y phase nung figure natin. So for the x phase, no, ang gagamitin natin dito is yung sigma as x coordinate and then yung tau natin as y coordinate. So for x phase, meron tayo dito 50 megapascal and then yung tau natin is 40. And then yung y phase naman natin is meron tayong negative 10 as sa sigma and negative 40 sa tau. So kaya naging negative 40 kasi yung sa y phase natin is kabaliktaran lang nung sign nung nasa x phase natin. So dito for demonstration, ang gagamitin ko is AutoCAD. Pero kapag magsasagot kayo ng mga activity natin, is magma-manual method kayo dito. Gamit yung drawing materials na pina-prepare ko sa inyo. Okay, so ipa-plot na. So simulan natin dun sa x phase coordinates natin. Okay, so first step natin dito is i-plot yung nasa points natin, yung sa x phase and sa y phase. So para ma-determine muna natin yung points, no, ang gagawin ko is gagawa muna ako ng maliit na circle. So ilo-locate ko lang siya dito. So kung mapapansin ninyo, no, binaliktad ko yung sign nung sa y coordinate natin. Dahil yun, di ba, kasi nga ang orientation natin sa Mohr circle is yung negative or yung positive natin na stress is nandito sa baba and yung negative naman is nandito sa taas, whereas sa AutoCAD is sumusunod dito doon sa Cartesian coordinate system natin. So after nyong i-plot yung dalawang points na yon, isang next yung gagawin is pag-connect sila sa isa't isa. So mag-drawing lang kayo ng straight line mula doon sa dalawang points na yon. So pwede ko na ngayon itong tanggalin. And then dito, no, sa pagkatapos nyo makagawa ng straight line, ang gagawin naman ninyo is hahanapin yung gitna nito. So paano nyo hahanapin? So pwede kayong gumamit ng equation of distance. Pwede kayong gumamit ng solving for distance ng line. So pwede naman ang gawin nyo is gamit yung ruler nyo is i-estimate nyo na lang. So kagaya for example doon ng pag-estimate na dito sa AutoCAD kasi is nilolocate niya na yung midpoint. So once na nalocate niyo yung midpoint, is gagawa na kayo dito ng circle na yung diameter natin is yung dalawang point na plinat ninyo. So pagkatapos ng i-plot, no, kailangan nating labelan yung dalawang points na yon. So dito kung mapapansin niyo is meron na akong prepare na mga pang-label para mabilis na lang din dito sa natin, tutorial. So ito naman, labelan lang natin yung second point. So pagkatapos yung labelan, no, yung point na yan, is mahanap na natin dito yung principal stress. So paano natin mahanap yung principal stress? So alam naman natin, di ba, ang principal stress natin is nasa x-axis. So dito, yung highest or maximum value natin pagdating dito sa x-axis is siya yung sigma 1 natin. And then yung minimum value naman is siya yung sigma 2. So pwede nyong gawin diyan, di ba, kung nakapag-drawing na kayo, is pwede nyong gamitin yung ruler ninyo para manually i-measure yung distance. So dito sa AutoCAD, so gagawin ko lang is check lang natin yung dimension. So dito is 70. So ang sagot natin for sigma 1 is 70 megapascal. So ito nga palang ano natin dito, no? For circle is in terms of megapascal. After natin makuha yung sigma 1, is ilocate na, kunin naman natin yung dimension or yung distance ng sigma 2. Sa pagkuha pala ng distance natin dito, ang reference point natin is yung origin and then yung second point. So dito naman is 30. Kaya lang, di ba, since nasa kaliwa siya nung coordinate system natin or coordinate plane, so negative ito pagdating sa x-axis, di ba? So kaya ang sigma 2 natin is negative 30 megapascal. So, di ba ang pinapahanap din is yung average stress. So ano naman yung average stress natin dito? So yung average stress natin is yung distance mula dito sa center ng circle ninyo papunta doon sa point of origin. So gagawin nyo lang, i-measure nyo yung distance manually, pero dito sa AutoCAD is DLI. So ang distance natin dito is 20. Kaya lang, no, take note natin na kapag yung diameter naman ninyo is nandito sa kabilang side, no, isusundan natin yung sign convention kung nasaan ba siyang quadrant. So limbawa, di ba dito sa quadrant 1, yung x natin is positive. Sa quadrant 3, quadrant 4, ang x natin is positive. Sa quadrant 2, ang x natin is negative. And quadrant 3, ang x natin is negative. So kaya dito, yung average stress natin is 20. So paano naman yung tau max? So yung tau max naman natin dito, kung babalikan natin, di ba yung mga equations kanina na pinakita, sabi, yung tau max natin is yung highest na y value. So kung yung highest na y value, no, kung galing tayo dito sa center, so pwede nating sabihin siya rin yung radius. So ang gagawin ko lang dito is ipo-project ko lang, no, yung tau max natin mula dito sa midpoint and then papunta dito sa quadrant natin. And then measure lang natin yung distance. So ang distance natin is 50. So again, kaya positive kasi baliktad ang orientation natin pagdating sa Mohr circle. And then labelan nyo lang yung plot ninyo. So ngayon, ang kulang na lang natin is yung theta. So paano natin kukunin yung theta? So dito, no, pwede nyo gamitin yung protractor nyo. Pero sa AutoCAD is dimangular. So kunin lang natin yung theta. So yung angle natin dito is 53 degrees. Kaya lang, di ba sabi kanina, kapag inilabas natin sa Mohr circle, pag nasa Mohr circle tayo, ang theta natin is naka times 2. So kailangan natin tong i-divide by 2. So ang theta natin dito is 53 over 2 or 26.5. Okay, so ngayon, no, nakuha na natin yung mga hinahanap na value. So i-compare natin to doon sa mga na-compute nating value using equation method. Tignan natin kung meron ba tayong discrepancy. So i-compare naman natin yung sagot natin, no, doon sa Mohr circle compare doon sa sagot sa equation method. So ito yung answers dito, yung 26.5, 70, 30 megapascal, 50 megapascal, and 20 megapascal is ito yung nasa Mohr circle natin. And ito namang sagot na nandito sa kabila is ito yung sagot using equation method. So kung makikita natin, no, parehas yung nakuha nating sigma 1 and sigma 2, tau max and average stress. Ang pinagkaiba lang is dito sa theta natin. Whereas dito sa using AutoCAD or yung Mohr circle natin, no, is 26.5 degrees yung nakuhang sagot. Pero using equation method is 26.56501 degrees. So meron lang tayong discrepancy dito na 0.6501. So comparing these answers, no, napatunayan natin na parehas naman yung makukuha nating sagot kung gagamit tayo ng Mohr circle or equation method. And dyan natatapos yung lesson natin for Module 9. Thank you.